Welcome to Bridge Course by Siddhaganga. Good morning, all. Today, let us move on to the topic Introduction to Organic Chemistry. And as we know that the important branches in chemistry is physical chemistry, inorganic chemistry, and organic chemistry. In a previous classes, we discussed many things about the physical chemistry and inorganic chemistry. Today, let us move on to introduction to organic chemistry. Okay. So then, before going to the definition of this organic chemistry, let me give the introduction first. In 1780, Swedish chemist Berzelius, classified the chemical compounds into two categories. So, he classified the chemical compounds into two categories based on the source for the chemical compounds. So, there are two sources for the chemical compounds. One is the living sources from plants and animals. We can obtain those chemical compounds directly or indirectly from the living sources. Living sources means from plants and animals. Second one is the compounds are obtained from the non-living sources, that is from minerals and rocks and minerals. So he classified the chemical compounds into two types. So first one is compounds from living sources, and second one compounds from non-living sources. And he called all the chemical compounds which are from living sources, that is from plants and animals, directly or indirectly, as organic compounds. Whereas the compounds which are obtained from non-living sources, from minerals and the rocks, and he called those organic compounds as inorganic compounds. So, all chemical compounds are classified into two types: organic compounds, inorganic compounds. Organic compounds are obtained from the living sources, plants and animals, directly or indirectly. Inorganic compounds are obtained from the non-living sources, minerals or the rocks, and they are called inorganic compounds. This concept was given in the year 1780. According to Berzelius, organic compounds could be obtained only from the living sources, because the living sources, plants and animals, containing natural forces, and he called that natural forces as vital forces. So, according to Berzelius, he believed that organic compounds are obtained only from the living sources, as they are having vital forces. Vital forces means natural forces. Under the influence of vital forces, only in the presence of vital forces, organic compounds could be obtained. This is according to Berzelius. It means to say, according to Berzelius, the organic compounds could not be prepared artificially or by using a chemical method in the laboratory in the absence of vital forces. Berzelius prakara organic compounds na laboratory synthesis madakagalla. Andre artificial chemical method in the absence of vital forces, it is not possible to prepare organic compounds in the laboratory. This concept was according to Berzelius, and this concept leads to the which leads in the theory called vital force theory. Who proposed vital force theory? Berzelius proposed vital force theory in the year 1807. So who proposed vital force theory here? Berzelius proposed this vital force theory in the year 1807. So what this theory says? This theory says that organic compounds could be obtained from the natural sources only in the presence of vital forces. It could not be possible to prepare organic compounds in the laboratory by using chemical artificial methods. But later in 1828, German chemist Friedrich Euler, Friedrich Euler, Friedrich Euler prepared first organic compound called urea. First organic compound called urea. And this urea is obtained from ammonium cyanate. This is ammonium cyanate. When this ammonium cyanate heating, it rearrangement takes place to give urea. So this is urea. Okay. So this is the first organic compound urea synthesized by German chemist Friedrich Euler in the year 1828 in the laboratory. But this organic compound is obtained from inorganic compound. Ammonium cyanate is inorganic compound. Urea was the first organic compound synthesized in the laboratory in the absence of vital forces. It was prepared by Euler in the laboratory, but this urea is obtained from the inorganic compound ammonium cyanate. Later, soon after the preparation of this compound, first organic compound urea, the vital force theory was not disproved. ಅಂದ್ರೆ ವೈಟಲ್ ಫೋರ್ಸ್ ಥಿಯರಿ ಪ್ರಕಾರ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ ನ ನಾವು ಲ್ಯಾಬೊರೇಟರಿ ಸಿಂಥಸೈಸ್ ಮಾಡಕ್ ಆಗೋದೇ ಇಲ್ಲ ಅಂತ ಹೇಳಿದಾಗ ಸೂನ್ ಆಫ್ಟರ್ ದ ಪ್ರಿಪರೇಷನ್ ಆಫ್ ದಿಸ್ ಯೂರಿಯಾ ವೈಟಲ್ ಫೋರ್ಸ್ ಥಿಯರಿ ಡಿಸ್ಪ್ರೂವ್ ಆಗ್ಬೇಕಿತ್ತು ಬಟ್ ವೈಟಲ್ ಫೋರ್ಸ್ ಥಿಯರಿ ಹ್ಯಾಸ್ ನಾಟ್ ಡಿಸ್ಪ್ರೂವ್ಡ್ ಸೂನ್ ಆಫ್ಟರ್ ದ ಪ್ರಿಪರೇಷನ್ ಆಫ್ ಯೂರಿಯಾ ಲೇಟರ್ in 1845 Kolbe had synthesized first organic compound called acetic acid with the formula CH3COOH. He prepared organic compound say acetic acid with the formula CH3COOH from its elements. From its elements means by using carbon, hydrogen and oxygen. So this was the first organic compound which was prepared in the laboratory from its elements in the absence of vital forces. Okay. So soon after the preparation of this acetic acid, vital force theory was disproved because acetic acid was prepared in the laboratory by using artificial methods from its elements. And the next one in 1856, one more compound was synthesized by Berthelot. That compound is methane. Compound is methane with the formula CH4. This compound also prepared from its elements. So, vital force theory was proposed by Berzelius in the year 1807. But the vital force theory was not disproved after the preparation of urea in the laboratory. That was the first organic compound synthesized in the laboratory in the absence of vital forces. But vital force theory was not disproved soon after the formation of urea. The vital force theory was disproved only after the preparation of acetic acid and methane by Kolbe and Berthelot. Okay. So, which was the first organic compound synthesized in the laboratory? Andre, you had to say urea. Who proposed vital force theory? Definitely Berzelius proposed vital force theory. So, name the first organic compound synthesized in the laboratory from its elements. From its elements, it is nothing but acetic acid because urea is the first organic compound synthesized in the laboratory from inorganic compound. So, this was the introduction to the organic chemistry. Now, we can define what is organic chemistry. So, what is organic chemistry? Definitely, organic chemistry is a branch of chemistry which deals with the study of compounds of carbon. So, the branch of chemistry which deals with the study of compounds of carbon is called a branch called organic chemistry. Now, what are the important elements present in organic compounds? Mainly, it must contain carbon. Along with carbon, it must contain hydrogen. Along with the hydrogen, oxygen is also very important element present in organic compounds. But there are some elements which are nitrogen, sulfur, chlorine, bromine, iodine and phosphorus. These elements are the minor elements present in organic compounds, which means to say they are present as a traces. So traces of these elements are also present in organic compounds. But in organic compounds, carbon atoms are bonded to one another and atoms of other elements by a covalent bond. So in organic compounds, the carbon atom is bonded to hydrogen and oxygen and to carbon and to other elements through a bond called covalent bond. In the last class, I said what is a covalent bond? The sharing of the electron takes place between the two combining atoms that results in an attractive force, and that attractive force is nothing but a covalent bond. So in organic compounds, the attractive force between the combining atoms is covalent bonds, and hence organic compounds are also called covalent compounds. What is another name for organic compounds? Organic compounds are also called covalent compounds because the nature of the bond between the combining atoms here is covalent bonds. Therefore, they are called covalent compounds. Clear? Now, let us move on to the next one. Already we learnt about the inorganic compounds. Correct. Inorganic compounds can be obtained from the elements present in the periodic table. 118 elements are there in a periodic table, and out of which we are using only few elements for the preparation of organic compounds. But other elements, almost all the elements can be used for the preparation of inorganic compounds, because inorganic compounds are those compounds which are obtained from the elements in the periodic table other than the carbon. But organic compounds are nothing but the compounds of carbon. So mainly it must containing carbon. Only few other elements are present in organic compounds. But inorganic compounds can be obtained from many elements that are present in a periodic table. ಅಂದ್ರೆ ಅಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ನಾವು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಇನಾರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು ಅದರ್ ದ್ಯಾನ್ ದ ಕಾರ್ಬನ್. ಅಲ್ಲಿಗೆ ದ ನಂಬರ್ ಆಫ್ ಇನಾರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ಸ್ ಜಾಸ್ತಿ ಆಗಬೇಕು ಕಂಪೇರ್ ಟು ದಟ್ ಆಫ್ organic compounds. But here what happens? The number of organic compounds far exceed more and more compared to that of inorganic compounds. So organic compounds in a number ಜಾಸ್ತಿ ಇರುತ್ತೆ inorganic compounds ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ. In spite of we are using many minimum elements for the preparation of organic compounds. Organic compounds prepare ಮಾಡಕ್ಕೆ ಕಮ್ಮಿ elements use ಮಾಡಿದ್ರು ಕೂಡ number of organic compounds far exceed more and more compared to that of inorganic compounds. So then there must be some reason behind that, right? So what are the reasons why organic compounds are more in number compared to that of inorganic compounds? So let us consider one by one. The first condition or the first reason for that is tetravalency of carbon. Tetravalency of carbon. What do you mean by tetravalency? It forms 4 covalent bonds. It forms 4 covalent bonds. So electronic configuration 1s2, 2s1, 2px1, 2py1, 2pz1. This is in a excited state. Means in a ground state electronic configuration is 1s2, 2s2, 2px1, 2py1. And in excited state during bond formation, one of the electrons from 2s orbital is get transferred to 2pz orbital, and this transfer of electron from 2s to 2pz orbital is energetically feasible. Energetically feasible ಅಂದ್ರೆ ಸಾಧ್ಯತೆ ಇದೆ. ಆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜೆಟಿಕಲಿ ಸಾಧ್ಯತೆ ಇದೆ ಬಿಕಾಸ್ 4 ಬಾಂಡ್ ಕೆಪಾಸಿಟಿ ಬರುತ್ತೆ. 2 ಬಾಂಡ್ ಕೆಪಾಸಿಟಿ ಇದ್ದು 4 ಬಾಂಡ್ ಕೆಪಾಸಿಟಿ ಬರುತ್ತೆ ಕಾರ್ಬನ್ಗೆ. ಆಗ ನ್ಯಾಚುರಲ್ ಆಗಿ ಎನರ್ಜೆಟಿಕಲಿ ಫೀಸಿಬಲ್ ಆಗುತ್ತೆ ಟ್ರಾನ್ಸ್ಫರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ರಮ್ 2s orbital to 2pz orbital. Now we have, there are 4 half-filled orbital in the valence shell of carbon. Valence shell of carbon ಅಲ್ಲಿ 4 half-filled atomic orbital ಇರೋದ್ರಿಂದ they are eligible for bond formation. So ನಾನಿನ್ನೆ ಯಾವ ತರ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ, ಕೋವಲೆಂಟ್ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಹೇಳಿದ್ದೀನಿ. by the overlapping of half-filled atomic orbitals, that is according to valence bond theory ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಅದರ ಪ್ರಕಾರ there are 4 orbitals present in the valence shell of an atom, carbon atom, and they are half-filled and they are eligible for bond formation. They are eligible for bond formation ಅಂತ ಹೇಳಿದ್ದೀನಿ. So 4 ಇರೋದ್ರಿಂದ the valency is 4 and it forms 4 covalent bonds. This is the first reason. And the second reason is catenation property. Catenation property. So what do you mean by catenation? Catenation is nothing but self-linking of elements to form a long continuous carbon chain, and that chain may be straight or it may be branched or it may be cyclic. So when the atom of one element self-link ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So self-linking of the atoms with another same atom, and it forms a long continuous carbon chain that may be straight or it may be branched or it may be cyclic. That property is called catenation property. This property is commonly given by non-metals with a covalency 2 or 4. So ಅದರ covalency 2 or 4 ಇತ್ತು ಅಂದ್ರೆ ಅಥವಾ valency 2 or more than 2 ಅಥವಾ 4 ಇತ್ತು ಅಂದ್ರೆ ಈ ಪ್ರಾಪರ್ಟಿನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ. But out of other non-metals which are having the valency 2 and more than 4 ಅಂತ ಹೇಳಿದ್ರೆ ಅದರಲ್ಲಿ carbon shows the maximum catenation property. Carbon in the periodic table shows the maximum catenation property. Then what is the catenation property of carbon? Carbon linked with other carbon atoms and it forms continuous carbon chain. So ಈ ತರ continuous carbon chain, it may be straight or it may be branched or it may be cyclic in nature. So ಈ ತರ chain formation ಆಗುತ್ತೆ. So carbon chain may be straight, may be branched, may be cyclic. So because of this reason, the number of organic compounds are far exceed the total number of inorganic compounds. Cyclic compounds are not found in inorganic compound, but organic compounds ಅಲ್ಲಿ cyclic compounds ಇರುತ್ತೆ, aromatic, alicyclic, cyclo compounds ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾಕೆ ಆ category ಇದೆ organic compounds ಅಲ್ಲಿ ಅಂದ್ರೆ because of catenation property of the organic compound. Okay, now next one is, third one is, there are 4 types of carbon atoms. 4 types of carbon atoms in organic compounds. What are 4 types? When carbon atom is bonded to one other carbon atom, then it is called primary carbon. 1 degree carbon or the primary carbon. What is a primary carbon? A carbon atom linked with one other carbon atom is called a primary carbon. Second one, if a carbon atom linked to 2 other carbon atom, then it is called secondary carbon. 2 degree carbon, secondary carbon or the 2 degree carbon. If a carbon atom is attached to 3 other carbon atom, then it is called tertiary carbon, 3 degree carbon. So 4 types of carbon atoms, 1 degree, 2 degree, 3 degree. Last one is 4 degree carbon are quaternary carbon. This is quaternary because this carbon is bonded to 4 other carbon atoms. So there are 4 types of carbon atoms in the organic compounds. Because of that reason, the number of organic compounds are far exceed the total number of inorganic compounds. What are those 4 types of carbon atoms? 1 degree are primary carbon atom, 2 degree are secondary carbon atoms, 3 degree are tertiary carbon atom, and 4 degree are the quaternary carbon atom. So primary carbon means the carbon atom which is bonded to one other carbon. ಇಲ್ಲಿ ಎರಡು ಕಾರ್ಬನ್ primary ಆಗುತ್ತೆ. So if a carbon atom is bonded to 2 other carbon atoms, then it is secondary. But what about this? Primary, and this is also primary. And if a carbon atom is bonded to 3 other carbon atoms, then it is tertiary. If a carbon atom is bonded to 4 other carbon atoms, then it is 4 degree carbon or the quaternary carbon. So because of the presence of 4 types of carbon atoms, the number of organic compounds far exceeds the total number of inorganic compound. And the fourth one is the carbon atom forms a multiple bonds. Multiple bonds means it forms double bond and a triple bond. It forms double bond and the triple bond. Double bond with a triple bond formation magutte with the carbon atom and also with other elements. Not only with the carbon it forms double or a triple bond, it also forms multiple bonds with the other elements. So carbon ಮತ್ತೆ carbon ನಡುವೆ double bond ಬಂದಾಗ ನಾವು alkenes ಅಂತ ಒಂದು classify ಮಾಡ್ತೀವಿ. ಕಾರ್ಬನ್ ಮತ್ತೆ ಕಾರ್ಬನ್ ಮಧ್ಯೆ ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಬಂದಾಗ ಆಲ್ಕೈನ್ಸ್ ಅಂತ ಮತ್ತೆ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಿಸ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಇಸ್ ಪಾಸಿಬಲ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಮಲ್ಟಿಪಲ್ ಬಾಂಡ್ಸ್. ಸೊ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಸಿಂಗಲ್ ಬಾಂಡ್ ವಿತ್ ದ ಕಾರ್ಬನ್, it forms double bond with the carbon, it forms triple bond with the carbon. Not only that, it forms double bond with the oxygen also. ಇದು tetravalency ತೋರಿಸುತ್ತೆ. So it forms a double bond with the oxygen and it forms triple bond with the nitrogen and it forms double bond with the sulfur. Sulfur ಜೊತೆಗೆ double bond, oxygen ಜೊತೆಗೆ double bond, nitrogen ಜೊತೆಗೆ triple bond ನ formation ಮಾಡುತ್ತೆ. So due to the formation of multiple bonds with carbon and other elements, the number of organic compounds are more compared to that of inorganic compounds. And one more thing is, the ionization energy of this carbon is very, very high. 1085 kilojoules per mole ಇದೆ ionization enthalpy. Ionization enthalpy ಅಂದ್ರೆ in order to remove electron from the outermost shell of carbon, it demands 1085 kilojoule per mole of energy. ಅಲ್ಲಿಗೆ ಹೈ ಎನರ್ಜಿ ಡಿಮ್ಯಾಂಡ್ ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ನ ವ್ಯಾಲೆನ್ಸ್ ಶೆಲ್ ಇಂದ ನಾವು ಹೊರಗಡೆ ತೆಗೆಯಕ್ಕೆ ಆಗಲ್ಲ. ದೆನ್ ಇಟ್ ಈಸ್ ಇಂಪಾಸಿಬಲ್ ಟು ಫಾರ್ಮ್ ಎ ಕ್ಯಾಟಯಾನ್, C+ ಅಯಾನ್ ಫಾರ್ಮೇಶನ್ ಆಗಲ್ಲ. So transfer of the electron from the valence shell of carbon does not takes place because its ionization potential is very, very high and its electronegativity value is 2.5. And this electronegativity is 2.5 anta helidaga it is not very high and it is not very low. It is in between. Therefore, the carbon atom does not show a tendency either to receive an electron or to donate an electron. ಈ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಸೀವ್ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕೂ ಕೆಪಾಸಿಟಿ ಇಲ್ಲ, ಎಲೆಕ್ಟ್ರಾನ್ ನ ಡೊನೇಟ್ ಮಾಡೋಕ್ಕೂ ಕೆಪಾಸಿಟಿ ಇಲ್ಲ. ಅಯೋನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಹೈ ಇದೆ, ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಕಮ್ಮಿ ಇದೆ. ಇನ್ ಬಿಟ್ವೀನ್ ಇರೋದ್ರಿಂದ ಇಟ್ ಈಸ್ ನಾಟ್ ಇನ್ ಎ ಪೊಸಿಷನ್ ಟು ರಿಸೀವ್ ಅನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಲೈಕ್ ದಟ್ ಆಫ್ ಹ್ಯಾಲೋಜಿನ್ಸ್. It is not in a position to give an electron like that of alkali metal. Sodium tara electron na kodo anta ability nu illa. Because of that reason, it only shares the electron. Since it shares the electron, it forms covalent bonds. So these are the some reasons for why the number of organic compounds far exceed the total number of inorganic compounds. Now let us consider, as I said, it forms a multiple bond and the health. It forms a multiple bond. Now Consider few examples here. If a carbon forms a single bond, and if it forms only sigma bond, when it does not form any pi bond, then this is only single sigma bond. And if it is forms a double bond, we need to look at on either sides. Here double bond means one pi bond, one sigma bond. If it is a triple bond, then two pi bonds and one sigma bond. So carbon single bond formation agide andre only sigma bond, double bond ide andre one pi bond, one sigma bond, triple bond anta helidre two pi bonds and one sigma bond agutte. So this is why these are the reasons how the number of organic compounds are far exceed the total number of inorganic compounds. Now let us move on to the shapes of the organic compounds. What is the shape of organic compounds? Let us consider. So this is one of the important differences between organic and the inorganic compounds. So organic compound shows geometrical shape, geometrical particular shape, and inorganic compounds also shows geometrical shape, but inorganic compounds ಅಲ್ಲಿ ionic compounds ಅಂತ ಕೂಡ category ಬರುತ್ತೆ. Ionic compounds does not exhibit geometry. ಯಾವುದೇ ಅದಕ್ಕೆ particular shape ಇರಲ್ಲ. But inorganic compounds ಅಲ್ಲಿ geometrical shape ಇರುತ್ತೆ. But remember, one class of inorganic compounds ನ ನಾವು ionic compounds ಅಂತ ಕರಿತೀವಿ. That is, all ionic compounds are inorganic compounds. But all inorganic compounds are not ionic. Remember this, very important. All ionic compounds are inorganic, no doubt, and those ionic compounds does not give a geometrical shape, whereas all inorganic compounds are not ionic. Ella inorganic compounds na now ionic anta helakagalla, but ionic compounds are definitely inorganic in nature. Clear? And this is the one of the important differences that we can find. Organic compounds anta bandaga yava compound alli carbon ide, carbon compounds antivi, adara derivatives anta heltivi, alli ಒಂದು geometrical shape irutte. What is the reason for shape of organic compounds? So shape of organic compounds, shape of organic compounds. So how we can find the shape of organic compounds? Because carbon undergoes hybridization. It undergoes hybridization. It undergoes three types of hybridization. What do you mean by hybridization? Last class alli naan helide. I'll rewrite the electronic configuration of carbon. 2px, 2py1, 2pz1. As I said, there are 4 half-filled atomic orbitals are there in the valence shell of carbon, and they are eligible for bond formation. ಅಲ್ಲಿರುವಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಅದು ಶೇರ್ ಮಾಡಬಹುದು ಇನ್ನೊಂದು atoms ಜೊತೆಗೆ. But during sharing of these electrons, look at here, one electron is in 2s orbital, 3 electrons are in 2p orbital. 3 electrons 2p allidre 1 electron 2s allirutte. Therefore resulting molecule enagutte unstable agutte. Why it is unstable? Because of difference in the energy. Energy differ agutte, shape of the orbital kuda differ agutte. S orbital is spherical shape and its extent of overlapping is maximum, whereas p orbital double shape irutte, idara extent of overlapping is minimum compared to that of s orbital. So ee tara adaga definite agi resulting molecule become unstable. To get a stable molecule, we need an atomic orbital with the same energy and same shape. Shape same irbeku, energy same irbeku, aga enagutte resulting molecule will be stable. Therefore, because of that reason, the carbon undergoes hybridization. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಇನ್ನ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳಬೇಕು ಅಂದ್ರೆ ಒಂದು ಡ್ರಾಯಿಂಗ್ ನ ಬರ್ದಿರ್ತೀರಾ ನೀವು. ಡ್ರಾಯಿಂಗ್ ಬರ್ದಾಗ ಅದನ್ನ ಪೇಂಟ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ, ಕಲರ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ. ಕಲರ್ ಹಚ್ಬೇಕಾಗತ್ತೆ ಅದಕ್ಕೆ. ಸೊ ಆ ಕಲರಿಂಗ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಿಮಗೆ ಕಲರ್ ಬೇಕು, ಜಾಸ್ತಿ ಬೇಕು, ಕ್ವಾಂಟಿಟಿ ಜಾಸ್ತಿ ಬೇಕು. ಯಾವ್ದಾದ್ರು ಕಲರ್ ಆಗಿರ್ಲಿ, ಒಂದೇ ಕಲರ್ ಇದ್ರೂ ಸಾಕು, ಬಟ್ ಕ್ವಾಂಟಿಟಿ ಜಾಸ್ತಿ ಬೇಕು. ಬಟ್ ನಿಮ್ಮ ಹತ್ರ ಏನಿದೆ, 1 ml ವೈಟ್ ಕಲರ್ ಪೇಂಟ್ ಇದೆ, 2 ml ಬ್ಲಾಕ್ ಕಲರ್ ಇದೆ, 3 ml ರೆಡ್ ಕಲರ್ ಪೇಂಟ್ ಇದೆ. ನಿಮಗೆ 1 ಕಲರ್ ಬೇಕು, ಅವಾಗ ಕ್ವಾಂಟಿಟಿ ಜಾಸ್ತಿ ಬೇಕು. ಹಾಗೇನ್ ಮಾಡ್ತೀರಾ ನೀವು, ಮಿಕ್ಸ್ ಮಾಡ್ತೀರಾ. 1 ml ವೈಟ್ ಕಲರ್, 2 ml ಬ್ಲಾಕ್ ಕಲರ್, 3 ml ರೆಡ್ ಕಲರ್ ನ ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ ಟೋಟಲ್ 6 ml ಪೇಂಟ್ ಸಿಕ್ಕತ್ತೆ. ನಿಮಗೆ ಬೇಕಾಗಿರೋದು ಅದೇ. ಸೊ ನಾಟ್ ಎ ಕಲರ್ ಬಟ್ ಈಸ್ ದ ಕ್ವಾಂಟಿಟಿ. ಸೊ ಇನ್ ಅ ಸಿಮಿಲರ್ ವೇ ಇಲ್ಲೂ ಹಾಗೇನೆ ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಮಿಕ್ಸಿಂಗ್ ಆಫ್ atomic orbitals present in the valence shell of bonding atom takes place, so that redistribution of the energy takes place. ಇದರಲ್ಲಿರೋ ಎನರ್ಜಿ, ಇದ್ರಗಳಲ್ಲಿರುವಂತ ಎನರ್ಜಿ ಎಲ್ಲ ಮಿಕ್ಸ್ ಮಾಡಿ ರೀಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮಾಡ್ತಾರೆ. ಸೊ ರೀಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆದಾಗ ದೇ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಈಕ್ವಲ್ ಎನರ್ಜಿ. ಎನರ್ಜಿ ಸೇಮ್ ಆಗತ್ತೆ, ಶೇಪ್ ಆಫ್ ದ ಆರ್ಬಿಟಲ್ ಸೇಮ್ ಆಗತ್ತೆ, ದೇ ಆರ್ ಈಕ್ವಾಲೆಂಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಪ್ರಾಪರ್ಟಿ, ಶೇಪ್ ಅಂಡ್ ಆಲ್ಸೋ ಸೈಜ್. ಅಂದ್ರೆ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಕೆಪಾಸಿಟಿ ಸೇಮ್ ಆಗತ್ತೆ, ಶೇಪ್ ಸೇಮ್ ಆಗತ್ತೆ, ಎನರ್ಜಿ ಸೇಮ್ ಆಗತ್ತೆ. ಹೀಗೆ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆದ್ರೆ ಎನರ್ಜಿ ಡಿಫರ್ ಆಗತ್ತೆ, ಶೇಪ್ ಡಿಫರ್ ಆಗತ್ತೆ, ಕರೆಕ್ಟಾ, ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಡಿಫರ್ ಆಗತ್ತೆ, ರಿಸಲ್ಟಿಂಗ್ ಕಾಂಪೌಂಡ್ ಅನ್ಸ್ಟೇಬಲ್ ಆಗತ್ತೆ. ಯಾವಾಗ ನೀವು ಮಿಕ್ಸ್ ಮಾಡ್ತೀರಿ ಎನರ್ಜಿ ರೀಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗತ್ತೆ. ಎಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ನ ಮಿಕ್ಸ್ ಮಾಡ್ತಿರೋ ಅಷ್ಟೇ ಆರ್ಬಿಟಲ್ ಫಾರ್ಮೇಶನ್ ಆಗತ್ತೆ. ಬಟ್ the resulting orbitals are equivalent orbitals. Why they are called equivalent orbitals? They are equivalent with respect to shape, energy and property. And those equivalent orbitals which are obtained after mixing 2 or more atomic orbitals are slight differ in energy. Slight differ ಇರಬೇಕು. 2s ನ 4s 4p ಜೊತೆಗೆ ಮಿಕ್ಸ್ ಮಾಡಕ್ ಆಗಲ್ಲ. So there must be a slight difference in the energy. Then after mixing, whatever the atomic orbitals obtained are called equivalent atomic orbitals, and those equivalent atomic orbitals are called hybridized orbitals. Hybridized orbitals, and the phenomenon is called hybridization. A phenomenon ge navu en kariteve, hybridization anta kariteve. Allige carbon undergoes 3 types of hybridization. First one is sp3 hybridization. sp3 ಅಂತಂದ್ರೆ 1s ಆರ್ಬಿಟಲ್ 3p ಆರ್ಬಿಟಲ್. ಇಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಮಿಕ್ಸ್ ಆಗುತ್ತೆ. 1 2s ಆರ್ಬಿಟಲ್ ಅಂಡ್ 3 2p ಆರ್ಬಿಟಲ್ ಇಷ್ಟು ಮಿಕ್ಸ್ ಆದಾಗ 4sp3 ಹೈಬ್ರಿಡ್ ಆರ್ಬಿಟಲ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ. ಸೊ s ಆರ್ಬಿಟಲ್ ಸ್ಪೆರಿಕಲ್, ಇದು ಡಂಬಲ್ ಇರುತ್ತೆ. ಬಟ್ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆದ್ಮೇಲೆ ನೋಡಿ ಏನಾಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಶೇಪ್ ಆಫ್ ದ atomic orbitals. So this is the shape of the atomic orbitals. So hybridized orbitals na ನಾವು ಈ ತರ, this is the shape. ಲೂಪ್ ಒಂದು ದೊಡ್ಡದಿರುತ್ತೆ, ಇನ್ನೊಂದು ವೆರಿ ಸ್ಮಾಲ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಎನರ್ಜಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇಲ್ಲಿ ಇರುತ್ತೆ. ಆಗ overlapping is also maximum. After sp3 hybridization, they orient towards the 4 corners of the tetrahedral, and bond angle between each hybridized orbital is 109 degree 28 minutes, and that bond angle is called tetrahedral bond angle, and the geometry is tetrahedral geometry. ಅದಕ್ಕೆ ಟೆಟ್ರಾಹೆಡ್ರಲ್. ಕಾರ್ಬನ್ sp3 ಆಯ್ತು ಅಂದ್ರೆ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ವಾಟ್ ಈಸ್ ದ geometry ಅಂದ್ರೆ ಟೆಟ್ರಾಹೆಡ್ರಲ್ geometry ಅಂತ ನೀವು ಹೇಳ್ಬೇಕಾಗುತ್ತೆ. And second type of hybridization given by the carbon, second one is sp2 hybridization. sp2 hybridization ಅಂದ್ರೆ 1s orbital mixed with 2p orbital. ಅಲ್ಲಿಗೆ 2pz orbital free ಆಗತ್ತೆ. So 2pz orbital free ಅಂದ್ರೆ it is not involved in hybridization. ಯಾವಾಗ ಅದು ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಲ್ಲ, ಪ್ಯೂರ್ ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ ಹಾಗೆ ಇರುತ್ತೆ. ಯಾವಾಗ ಪ್ಯೂರ್ ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ ಆಗಿರುತ್ತೋ ದಟ್ ಕ್ಯಾನ್ ಫಾರ್ಮ್ ಎ ಪೈ ಬಾಂಡ್. ಒಂದು 2p ಆರ್ಬಿಟಲ್ ಫ್ರೀ ಆಯ್ತು ಅಂದ್ರೆ ಇಟ್ ಕ್ಯಾನ್ ಫಾರ್ಮ್ ಎ ಪೈ ಬಾಂಡ್, ಒಂದು ಸಿಂಗಲ್ ಪೈ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ. ನಾನು ಹೇಳಿದ್ದೆ ನಿನ್ನೆ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ವಾಟ್ ಆರ್ ದ ಕಂಡೀಷನ್ಸ್ ಫಾರ್ ದ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಎ ಪೈ ಬಾಂಡ್. ಸೊ ಪೈ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ಬೇಕಾದ್ರೆ ಅಟೋಮಿಕ್ ಆರ್ಬಿಟಲ್ಸ್ ಹೈಬ್ರಿಡೈಸ್ ಆಗಿರಬಾರ್ದು. ದೇ ಮಸ್ಟ್ ಬಿ ಪ್ಯೂರ್, half filled, and ಅದರ ಪೊಸಿಷನ್ ಹೇಗಿರ್ಬೇಕು, ಪ್ಯಾರಲಲ್ ಟು ಈಚ್ ಅದರ್ ಅಂಡ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದ ಆಕ್ಸಿಸ್. ಇಂಟರ್ನ್ಯೂಕ್ಲಿಯರ್ ಆಕ್ಸಿಸ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇರಬೇಕು, ಪಿ ಆರ್ಬಿಟಲ್ಸ್ ಪ್ಯಾರಲಲ್ ಇರಬೇಕು, ಸೈಡ್ ವೇಸ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆದಾಗ ಪೈ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ. ದೀಸ್ ಆರ್ ದ ಕಂಡೀಷನ್ಸ್. ಸೊ ಇಲ್ಲಿ ಒಂದು 2p-z ಆರ್ಬಿಟಲ್ ಪ್ಯೂರ್ ಆರ್ಬಿಟಲ್ ಹಾಗೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ, ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಲ್ಲ. therefore it forms one pi bond. ಅಲ್ಲಿಗೆ 2sp2 hybridization ಆಯ್ತು ಕಾರ್ಬನ್ ಅಂದ್ರೆ it gives 3sp2 hybrid orbitals. So 3sp2 hybrid orbitals orient themselves to three corners of the trigonal. Three corners of the trigonal, and the bond angle is 120. Fix ಆಗತ್ತೆ ಇದು triangular planar. What is the geometry? Triangular planar. Triangular planar is the geometry of the molecule if a carbon undergoes sp2 hybridization. So the third one is sp hybridization. sp hybridization. sp means 1s combines with 1p. ಒಂದೇ ಒಂದು p ಆರ್ಬಿಟಲ್ ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತೆ, ಅಲ್ಲಿಗೆ 2py ಮತ್ತೆ 2pz ಆರ್ಬಿಟಲ್ಸ್ ಏನಾಗುತ್ತೆ ಹಾಗೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ 2p ಆರ್ಬಿಟಲ್ಸ್ ಪ್ಯೂರ್ ಆರ್ಬಿಟಲ್ಸ್ ಉಳ್ಕೊಂಡಾಗ ಇಟ್ ಕ್ಯಾನ್ ಫಾರ್ಮ್ 2 pi bonds. ಅಂದ್ರೆ sp ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಲ್ಲಿ 2 pi bond ಫಾರ್ಮೇಶನ್ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ, sp2 ಅಲ್ಲಿ 1 pi bond ಫಾರ್ಮೇಶನ್, sp3 ಅಲ್ಲಿ ನೋ pi bond ಫಾರ್ಮೇಶನ್ ಆಗಲ್ಲ. ಸೊ sp2 ಅಲ್ಲಿ 1 pi bond. ಸೊ sp ಅಂತ ಹೇಳಿದ್ರೆ 2 pi bonds. ಅಲ್ಲಿಗೆ so it gives 2 sp hybrid orbital. After hybridization they orient themselves to an angle 180 degree. Particular angle ಕೂಡ ಫಿಕ್ಸ್ ಆಗುತ್ತೆ. sp3 ಅಂದ್ರೆ ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಆಂಗಲ್ 109 degree 28 minutes, ಇಲ್ಲಿ 120 degree, ಇಲ್ಲಿ 180 degree. So geometry is linear. Geometry ಏನಾಗುತ್ತೆ ಲೀನಿಯರ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ how to find out the state of hybridization of carbon in a given molecule? ಕೊಟ್ಟಿರೋಂಥ ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ ನೀವು ಹೈಬ್ರಿಡೈಸೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ ಕಾರ್ಬನ್ ನ ಹೇಗೆ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತೀರಾ? ವೆರಿ ಸಿಂಪಲ್. ಇಫ್ ಕಾರ್ಬನ್ ಫಾರ್ಮ್ಸ್ ಓನ್ಲಿ ಎ ಸಿಂಗಲ್ ಬಾಂಡ್ ಅಂದ್ರೆ ಸಿಗ್ಮಾ ಆಗುತ್ತೆ, ನೋ ಪೈ ಬಾಂಡ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿಗೆ ಹೈಬ್ರಿಡೈಸೇಷನ್ ಏನಾಗುತ್ತೆ ಇದು? ಸೊ ಓನ್ಲಿ ಸಿಂಗಲ್ ಬಾಂಡೆಡ್ ಕಾರ್ಬನ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ ನೋ ಪೈ ಬಾಂಡ್, ಅಲ್ಲಿಗೆ ಜೊಮೆಟ್ರಿ ಇಸ್ sp3. ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಸಿಂಗಲ್ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಆಗಿದ್ರೆ sp3. ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್, ಡಬಲ್ ಅಂದ್ರೆ 1 pi bond ಫಾರ್ಮೇಶನ್ ಆಗಿದ್ರೆ, 1 pi bond ಫಾರ್ಮೇಶನ್ ಮಾಡಿದ್ರೆ ಯು ನೀಡ್ ಟು ಲುಕ್ ಆನ್ ಐದರ್ ಸೈಡ್ಸ್ ಆಫ್ ದ ಕಾರ್ಬನ್. ಎರಡೂ ಕಡೆಗೂ ನೋಡ್ಬೇಕು. ಓನ್ಲಿ 1 pi bond ಇತ್ತು ಅಂದ್ರೆ ದೆನ್ ಇಟ್ ಈಸ್ sp2. ಸೊ 2 pi bond ಫಾರ್ಮೇಶನ್ ಮಾಡಿದ್ರೆ, ಇಫ್ ಎ ಕಾರ್ಬನ್ ಫಾರ್ಮ್ಸ್ 2 pi bonds then it is sp. So sp. So no pi bond sp3, 1 pi bond sp2, 2 pi bonds sp. ಸಿಂಗಲ್ ಬಾಂಡ್ ಅಂದ್ರೆ ಪೈ ಬಾಂಡ್ ಇರಲ್ಲ, ಡಬಲ್ ಬಾಂಡ್ ಅಂದ್ರೆ 1 pi bond ಇರುತ್ತೆ, 1 ಸಿಗ್ಮಾ ಬಾಂಡ್ ಇರುತ್ತೆ, ಜೊತೆಗೆ ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಅಂದ್ರೆ 2 pi bonds ಇರುತ್ತೆ, 1 ಸಿಗ್ಮಾ ಬಾಂಡ್ ಇರುತ್ತೆ. On the basis of this you can find out the state of hybridization of the carbon. Now let me give few examples for this. So identify the state of hybridization of the carbon in the following compounds. Simple. I'll give second one CH3, CH double bond CH, C triple bond CH. Third one CH2 double bond C double bond CH, CH3. So here we have 1, 2, 3 carbon. Give the state of hybridization of each carbon in the molecule. Look at this carbon. It forms only one single bond with the other carbon. Only single bond with the carbon. Like one sigma bond. It does not forming any pi bond. Therefore, it is sp3. Correct? And look at this carbon. Illi sigma bond ide, but illi double bond formation madide. Double bond means one pi bond, one sigma bond. Allige this carbon forms one pi bond. Therefore, it is sp2. This carbon also forms one pi bond, therefore it is also sp2. Like this. Look at here, carbon number 1, 2, 3, 4, 5. Here it forms sigma bond, therefore it is sp3. Here it forms one pi bond, therefore it is sp2. And here it forms one pi bond, one sigma bond. One pi bond ಮಾಡಿರೋದ್ರಿಂದ it is sp2. Here it forms two pi bonds. Triple bond ಅಲ್ಲಿ two pi bonds, one sigma bond ಇರುತ್ತೆ. This is sp and this is also sp hybridization. Look at here. ಇಲ್ಲಿ double bond ಇದೆ, one pi bond, one the sigma bond. This carbon forms one pi bond, therefore it is sp2. Look at the second carbon. ಇಲ್ಲಿ one pi bond, ಇಲ್ಲಿ one pi bond. ಅಲ್ಲಿಗೆ total two pi bond formation ಆಗಿದೆ. Hybridization state is sp. This carbon forms one pi bond, ಇಲ್ಲಿ sigma bond ಇದೆ. Total number of pi bond is 1, therefore it is sp2. ಇಲ್ಲಿ ಯಾವುದೇ pi bond formation ಆಗಿಲ್ಲ, only sigma bond ಇದೆ, therefore it is sp3. In that way, we have to identify the nature of state of hybridization of the carbon. So I'll give one more example. CH3, C double bond O, CH3. Similarly, fifth one, CH3, C triple bond N. Now you give the state of hybridization of the carbon in this molecule. So this carbon is only forming sigma bond, therefore it is sp3. But this carbon here forms sigma bond, but with oxygen it forms one pi bond, therefore it is sp2. This carbon is sp3 because it is forming only sigma bond. And look at here, this carbon forms only sigma bond here, therefore it is sp3. Correct? But with the nitrogen it is forming three bonds. Alli three bonds andre two pi bonds and one sigma bond. Therefore this carbon is sp hybridization. Okay? So single bond, no pi bond, only sigma bond, it is sp3. Forming one pi bond, sp2, and forming two pi bonds, it is sp hybridization. What is the geometry of the molecule? If a carbon is sp3, tetrahedral. What is its bond angle? 109 degree 28 minutes. If a carbon gives sp2 hybridization, what is the bond angle? 120 degree. It is fixed. And what is the geometry or the shape? It is triangular planar. Planar means all the atoms are present in one plane. And the third one, if it undergoes sp hybridization, what is the bond angle? Definitely 180 degree. And what is the geometry? Linear geometry. So now I'll conclude this one. Catenation property. What is catenation? One of the reasons why the number of organic compounds are far exceed the total number of inorganic compounds. That is tendency of an element to form chains with identical atoms. Identical atoms ಜೊತೆಗೆ bond formation ಮಾಡಿ chain formation ಮಾಡಿದ್ರೆ that tendency is called catenation ಅಂತ ಕರಿತೀವಿ. Second one is ability of a carbon atom to link with each other to form a long chain and a closed chain molecule. This is the tendency of a carbon atom. Therefore, the number of organic compounds are maximum. Non-metals with covalency 2 or more show catenation. Covalency ಎರಡಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ catenation property na exhibit ಮಾಡುತ್ತೆ. But out of those non-metals, carbon shows a maximum catenation. Clear? Next one. Types of carbon atoms. There are 4 types of carbon atoms. Primary carbon, secondary carbon, tertiary carbon, quaternary carbon. 1 degree, 2 degree, 3 degree, 4 degree carbon atoms. So, a carbon atom linked to only one other carbon atom is called primary. It should be linked to only one other ಕಾರ್ಬನ್ನೇ ಆಗಿರಬೇಕು. So a carbon atom linked to two other carbon atoms is called secondary. A carbon atom linked to three other carbon atoms is called tertiary carbon, 3-degree carbon. Carbon atom linked to four other carbon atoms is called quaternary carbon atoms. Now move on to the shapes of carbon compounds. Because of hybridization of the carbon, so it shows a particular geometrical shape for the organic compounds. So it shows a tetravalency as it's having four half-filled orbitals in the valence shell. So types of hybridization showed by the carbon atom in organic compound, three types: sp3, sp2 and sp. So number of bonds between the carbon atoms ಏನಿರುತ್ತೆ, sp3 ಅಲ್ಲಿ single bond, sp2 ಅಂದ್ರೆ double bond, sp ಅಂದ್ರೆ triple bond ಇರುತ್ತೆ. What is the percentage of s character? s character ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ S character. So sp3 hybridization ಹೇಳ್ತೀವಿ, 4 ಇದೆ, 100% ಅಂದ್ರೆ 100 divided by 4 ಅಂತ ಹೇಳಿದ್ರೆ around 25% of S character, 75% of P character ಆಗುತ್ತೆ. ಹಾಗೇನೇ sp2 hybridization ಅಲ್ಲಿ so 100 by 3 ಆಗುತ್ತೆ, ಅಲ್ಲಿಗೆ 1 molecule 1 orbital 33.3% S character and remaining 66.66% P character ಆಗುತ್ತೆ. ಅಂದ್ರೆ P percentage of P character ಜಾಸ್ತಿ ಇರುತ್ತೆ. So character ಅಂದ್ರೆ ಏನು? Electron density in the S orbital. Here it is 25% electron density S ಅಲ್ಲಿ ಇದ್ರೆ 75% electron density P ಅಲ್ಲಿ ಇರುತ್ತೆ. ಆಗ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆಫ್ ದ ಅಟಾಮಿಕ್ ಆರ್ಬಿಟಲ್ಸ್ ಅಂತ ಬಂದಾಗ ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಇಲ್ಲಿ ಕಮ್ಮಿ ಆಗುತ್ತೆ, ಯಾಕಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಕಮ್ಮಿ ಇರುತ್ತೆ, ವಿಚ್ ಇಸ್ ನಿಯರ್ ಟು ದ ನ್ಯೂಕ್ಲಿಯಸ್. ನ್ಯೂಕ್ಲಿಯಸ್ ಆದ್ಮೇಲೆ ಫಸ್ಟ್ ಬರೋದು ಎಸ್ ಆರ್ಬಿಟಲ್, ಅದಾದ್ಮೇಲೆ ಪಿ ಆರ್ಬಿಟಲ್ ಬರೋದು. ಪಿ ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೆ ಓವರ್ಲ್ಯಾಪಿಂಗ್, ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಲೆಸ್ ಆಗುತ್ತೆ. ಯಾಕೆ? ಬಿಕಾಸ್ ದ ಶೇಪ್ ಆಫ್ ದ ಪಿ ಆರ್ಬಿಟಲ್ ಈಸ್ ಡಂಬಲ್ ಶೇಪ್. ಕರೆಕ್ಟಾ? ಬಟ್ sp2 hybridization ಗೆ ಹೋದಾಗ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಪರ್ಸೆಂಟೇಜ್ ಆಫ್ ಎಸ್ ಕ್ಯಾರೆಕ್ಟರ್ ಏನಾಗುತ್ತೆ? 33 ಆಗುತ್ತೆ. ಇಲ್ಲಿಗಿಂತ ಇಲ್ಲಿಗೆ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. when the percentage of S character increases, its overlapping, extent of overlapping increases. ಅಂದ್ರೆ ಆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಆಫ್ ಎ ನ್ಯೂಕ್ಲಿಯಸ್ ಏನಾಗುತ್ತೆ? ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿಗೆ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಆಫ್ ದ ಕಾರ್ಬನ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿಗಿಂತ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. sp hybridization ಎರಡೇ ಎರಡು ಆರ್ಬಿಟಲ್ ಇದೆ, ಹಾಗಾಗಿ 50% S ಕ್ಯಾರೆಕ್ಟರ್ and 50% P ಕ್ಯಾರೆಕ್ಟರ್. ನೋಡಿ 25% ಇಂದ 50% ಗೆ S ಕ್ಯಾರೆಕ್ಟರ್ ಇನ್ಕ್ರೀಸ್ ಆದಾಗ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಆಲ್ಸೋ ಇನ್ಕ್ರೀಸಸ್. ಅಲ್ಲಿಗೆ ಸಿಂಗಲ್ ಬಾಂಡೆಡ್ ಕಾರ್ಬನ್ ಅಂದ್ರೆ ಲೆಸ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್, ಡಬಲ್ ಕಾರ್ಬನ್ ಬಾಂಡೆಡ್ ಕಾರ್ಬನ್ is more electronegative, triple bonded carbon is still more electronegative. Percentage of S orbital increase ಆಗ್ತಾ ಹೋದಾಗೂ percentage of S character increase ಆಗ್ತಾ ಹೋದಾಗೂ the electronegativity of the carbon also increases, because electron density is the S orbital increases, its force of attraction by the nucleus also increases because it is very near to the nucleus. Clear? So electronegativity of the carbon depends on percentage of S character. Percentage of S character depends on state of hybridization of the carbon, sp3, sp2, sp. So electronegativity of the carbon atom is based on the hybridization. The order of electronegativity, it is given in the increasing order. sp3 hybridized carbon is less electronegative compared to that of sp2 hybridized carbon, which is less electronegative compared to that of sp hybridized carbon. So this is the electronegativity. Electronegativity of the carbon increases with increase in the percentage of S character in the hybrid orbitals. So on the basis of hybridization, we can predict the state of hybridization of the carbon. So that gives the shape of the different organic compound based on the hybridization. whatever the introduction given today, the concepts are very, very important, and all these are basics to organic chemistry. Please go through this properly, and thank you. Thank you very much.